So hello, everyone. My name is Iran, and I'm a consultant in AWS. And we have today Yuri here, and he will talk about some interesting new features that can simplify your IAM policies. Hi, Yuri.
Hi, Iran. Hello. I am Yuri Dukovny, Solutions Architect with AWS. Today, we will talk about how you can simplify your AWS IAM access control policies using a new IAM feature called session tags. As you may already know, you can tag AWS resources and even tag AWS IAM users and roles. And today, we'll talk about a new feature that allows to tag IAM sessions when user logs in using a federated identity with either SAML or OpenID Connect. We'll show how you can pass attributes from your corporate directory to the IAM session and how to use these attributes as IAM policy condition keys to create a reusable, easy to scale, least privilege policies, giving developers freedom to build while keeping the right guardrails. The least privilege principle has been around before the internet was created and before computers were commonplace. But this is an everlasting journey. On one hand, we have builders who want to build without having to wait for anyone to give them permissions. And on the other hand, we want to make sure they can do so with the confidence that they cannot do anything dangerous and only have access to their own resources. Often, when you are in the journey to the access control confidence, it may become hard to manage a large number of IAM policies. And we are going to demo today how to address this challenge. But first, let's go over two common permission models: role-based access control and attribute-based access control. Role-based access control has been around for a long time. And this is what most of the industry has operated for years. Job roles were assigned to the identities, like users and applications, in order to grant access to the resources.
All right, so what is the challenge with this approach?
Nothing inherently wrong with it, but imagine you have thousands of users, hundreds of projects, and thousands of resources. It may be hard to scale. You continuously need to create your identities in your identity provider, then map them to the roles, and each role has policy that allows access to the specific set of resources. Resources are changing, users are moving teams or projects, and projects are changing, and the more fine-grained permission you want to have, the more roles and policies you need to create and maintain.
Okay, so this is where attribute-based access control comes to the rescue?
As always, the answer is it depends, but for many use cases, attribute-based access control can simplify the permission model and make it much easier to scale. In attribute-based access control model, you have attributes on your identities and attributes on your resources. Then the permissions just ensures those match. Attributes are handled in AWS using tags. You can tag resources, you can tag IAM users and roles, and now you can also carry attributes over from your identity provider through the SAML exception, and then use them to check permissions.
Okay, so how is that making it easier to scale?
If, for example, I want to move someone from one project to another, all I have to do is to change the attribute in the corporate directory without any changes in AWS.
All right, this sounds great, great benefit to the security teams. What are the benefits, let's say, to developers?
This allows developers to have freedom within guardrails. For example, they can create and access resources in their project without having to submit ticket to an administrator.
So this sounds great. So how do we get there?
So before we jump into how and the demos, I'd like to provide a quick overview of terminology to anyone relatively new to AWS and IAM. We'll keep it brief, so if you're already familiar with this, please stay with us. AWS supports several identity methods. First, you can create individual IAM users and assign them to groups and attach permission policies. Second, you can create roles that can be assumed by users, services, or resources, such as EC2 or Lambda. Roles can also be assumed by users from an external identity provider, user federation, with SAML or OpenID Connect. These users don't have an IAM user in AWS, and what they have is the session instead. The session operates within the policies attached to the role that has been assumed. The identity provider passes the role name in the SAML response as an attribute, and AWS recognizes it.
So the IDP needs to be aware of the roles in AWS in order for administrators to associate them to users. It needs to have some sort of knowledge of what roles are, and it's kind of tied to a specific account.
Right. And with multiple accounts, it becomes more and more complex to manage. Okay. Right. So another topic that I'd like to refresh is IAM policy syntax. And I'm sure it looks very familiar to many of you. IAM policies operate in what we call the park model, where principal A for P is who is doing the action. That can be user, role, service, and so on. Action is what the principal is allowed or denied to do. Resource is where or on what resource the action can operate. Condition is when to allow and when to deny based on conditions and context. Conditions are extremely powerful, and we'll use them today to simplify our fine-grained policies.
All right. So now that we have the building blocks covered, how do we use all that to implement attribute-based access control?
Let's start from the simplest policy and evolve it step by step. We'll use AWS Secrets Manager today for most of our demos and examples. So let's look at the policy that simply allows read and write actions on the specific Secrets Manager secret. Any issues you can spot here?
Well, it looks like we're very specific about the resource. So if we want to add another secret to that project, we'll need to update the policy and add another resource. And this is where I have a feeling we'll be talking about tags, right?
Exactly. Let's use the resource tag condition key to address that. Resource tags is not the new feature. We always had tags on resources, and we could write permissions with a condition that matches the resource tag to some hard-coded value. This means that each project needs a new policy, and this is hard to scale again when there are a lot of projects.
Okay. So this still looks like an improvement over the previous policy. Now, if a new resource is created with the right tag, the policy doesn't need to change. It seems great, right? So what's the problem of doing it like this?
Well, hard-coded values are always not the best. And imagine you need to add a new user to the new project. You now need to create a new role, a new policy, and also map the new user to that new role in your identity provider.
Okay. So I think we had enough slides by now. How about we show that in the console before we move on?
With my pleasure. Let's jump to the demo. First, let's take a look on our resources. For simplicity, we'll just look at AWS Secrets Manager. As you can see, we have two secrets. Both are tagged with project tag key. The first one tagged with value project 1. and the second one tagged with the value of project 2.
All right.
And this is how we will test our access control. And let's look at configuration that I created for Alice already. Let's say Alice belongs already to project 1, right? So I created role ASM project 1, and I have policy ASM project 1 attached to it. And this is the same policy that we saw in the slide. And I also have ASM common, which gives some read-only access and access to the KMS keys that Secrets Manager uses.
Okay.
So now let's imagine we need to create a new project, project 2, and we need to add user Bob to that project and to have Bob working with the resources of the project 2.
Okay.
Okay. So what should we do first? We need to copy our policy. We start from here, and we create new policy. And we change the value of project 1 to project 2. So if we have more projects, we will keep doing that. And we will call this policy SM project 2. Create. Now we need to create
another role. Yeah.
Let's create role. And we will create role for SAML Federation. And I already have IAM on my account integrated with Okta. And we will be using Okta for our demo today. It works similar with other identity providers as well. So let's add permissions to that role. Yeah, oops. We will not tag the role at all for now, and we will call it SM project 2 and create the role.
All right. Yeah, I can see how this is going to be harder to scale. Yeah.
Yeah, and this is not all, right?
All right.
Yeah, that's not all. We created role and policy, and we didn't do anything on our identity provider. It has no idea now about the new role. Right. So we have to go to Okta, and this is Okta Administrative Console. And I have Amazon Web Services application created already. So I need to go there, and Okta has this feature that uses pre-created user with list-only privileges in IAM to get roles and policies in.
Okay, so it can list the roles so we can display, so you can select them. Okay.
Yeah, right. The Okta will know about those roles. So you need to go into provisioning and quickly disable and enable this feature again to pull the roles list.
It's probably doing it periodically, but we want to kind of speed it up.
Yeah, so we'll do it quickly. So now Okta pulled the list of the roles
including the new role we just
IAM, including the new role. Yeah, and don't be afraid, it doesn't create any users. It really uses only read-only permissions on AWS side. And now, so now we refresh this, and now we are going and assigning this role to the users.
Okay. So Alice is already set up, but now we need to set it up for Bob on project 2.
All right. So we found Bob, and this is our roles, and we will use ASM project 2 that we just created. Done. So now Bob can access the resources of the project 2. Let's quickly test it.
Yeah.
So I'm still logged in as Alice. Let's log in with Bob credentials. Yep, Bob got a new application, and let's try to log in. Yes, and we are here in AWS console.
All right, and maybe you'll show how the access pattern, so they can go to secrets manager.
Yeah, let's go to the secrets manager. Let's try to access project one secret, and it
Which
fails.
as expected, it fails because
right, because
the tag
it's
doesn't match.
tagged with the project one. And let's try to access project two resource, and yes, Bob can access, and Bob can retrieve the secret value.
Okay, so I can see how this can be a little bit harder to scale if you have a lot of projects, a lot of users. So is there any way to replace that hard-coded value in the policy with something more dynamic?
Yeah, and let's talk about it. So let's go back to the diagram and let's introduce another condition key that's called PrincipalTag. We are moving from policy per project to a single or shared policy. And now we can tag IAM users and roles. We can have a condition that matches the principal tag to the resource tag.
What is a principal tag?
In this case, it's a tag on IAM user or role. And because we are using the federated identities, we will tag the role for that.
Sounds fantastic. So what's the issue with that?
There is no issue, but we need to tag the principal somehow. And we place tags on the roles, and inherently we will have multiple roles that will share the same policy, but just for sake of having tags on it.
Okay, so basically all the roles looks the same, just with different tags. All of them use the same policy.
Exactly.
So it's a little bit better, but okay, we'll see how we can improve it later.
Yeah, let's keep going. And this is how the policy looks like. We simply replaced the hard-coded value with the principal tag variable or condition key.
Right. This sounds great. It looks like this covers reading and writing secrets. But let's say if a new secret needs to be created. Let's say Alice, in our case, she still needs to submit a ticket and wait for someone with permissions to create that secret and tag it with project one, and same for Bob and all that. So is there a way to also let developers create resources?
Yes, this is where RequestTag condition key becomes useful. In order to allow users to create and tag resources, we need to enforce that these tags are in accordance to the permission guardrails and naming conventions. To do so, we'll use two IAM global condition keys, RequestTag and Tagkeys. And this is how the policy will look like in this case. First, we added the relevant actions to create a tag on the resource. Then we added a condition that matches the request tag. And the request tag is the tag that comes as part of the action that creates or tags the resource. For example, create secret or tag resource pass a set of tags as part of the parameters. Note that you can match more than one tag in the condition key as department, cost center, not only the project, and they will be evaluated using logical AND between them. We will use project in our examples.
Okay, so what is that if exists at the end of the string equals if exists? Well, why do we have that?
This is because request tag condition key is only applicable to some actions in our list. If it's not applicable, it evaluates as true.
Okay, right. So it's only relevant for create secret and tag resource, and for other actions we just don't evaluate that. Okay, so are there any other interesting condition keys that we can use to further improve the policy?
Sure, I hope you would ask. We will use two more condition keys. Tag keys that defines what tag keys are allowed in the request, and for all values that returns true if every value in the request matches at least one value in the list. As the result, with this condition that you can see on this slide, when resource being created, it can only be tagged using these tag keys. It also enforces case sensitivity So the tag keys will always be the same for consistency.
All right, so you won't have lowercase project, uppercase project, mixed case. So is there any other, can we enforce other naming convention, not just on the tags?
Yeah, so we definitely can. And we add a little touch to the policy. In this example, we use PrincipalTag and RequestTag condition keys to enforce the format of the secret manager resource name and the name tag on it, both to start with the project name.
Okay, so this sounds fantastic. So we covered a lot of conditions, and it looks like our policy is ready to test. Should we maybe jump to the console and apply what we just did?
Yes, let's try it. First of all, let's create the policy that we just discussed. A new policy. Yeah, that's exactly the same policy that you just saw. And we call it ASM ABAC, because we will use it for attribute-based access control for all our future demos.
Mm-hmm.
We created this policy. I will take the role ASM project 1, and I will change it. So first of all, I will remove the policy with the
hard-coded value?
With the hard-coded value project 1, exactly.
Yep, we don't want that.
And I will attach policy ASM ABAC that compares everything to PrincipalTag and allows to create a resource. But to make this working, I need to tag this role as we discussed.
Right, because the value is no longer in the policy, and we need to tag the principal.
Right, and this is how we tag principal in this case.
Okay, so now we need to do the same thing for project 2, right?
Exactly. So let's take project 2 role. We remove the project 2 static policy, and we attach the same policy. So yes, we are already saving here. We are using the same policy for all our projects, but we are still tagging the roles and use multiple roles. Okay. Now in Okta, we already have Bob and Alice assigned to the roles project 1 and project 2.
Right, so we
don't need to change in this case anything. But in the future, if you add Carol, you need to assign project 3, for example.
Right, we need to create a new role and assign it in the IDP. So
yeah,
less work, but still some work. Okay.
Yeah, so I'm still logged in as Bob to my IDP. So let's go to the console and test what did we get. So let's go to the secrets manager and let's try again to access project 1 secrets.
As expected.
As expected, it fails. And yes, we can access the project 2 secret.
So let's see how we can create a new resource.
All right, we just enabled Bob to create the new resource. So let's do that. Let's choose the key. And let's say Bob is trying to break the rules. He's trying to create the resource that belongs not to his project.
So he's a project 2, so we're going to try to create it in project 1.
Yes. And let's tag it with project 1.
Okay. So this is supposed to fail.
Yeah, we want this to fail, so let's
We want this to fail, right?
Yes.
Excellent. All right.
And let's change it to what's supposed to work. So yeah, Bob should be able to do that.
Yeah, he has all the right tags with the right format.
Yep.
And is able to create. And now someone else on the same project will be able to access that without changing any policies because the project is being tagged correctly.
Yes, exactly.
All right. So it seems like we have everything working great now. So Are there any issues?
All these can work, but you still need to maintain multiple roles just for the sake of tagging. And this is where session tags become useful. Session tags allow the identity provider to stay the source of truth and to enjoy the scalability benefits of ABAC. With session tags, we configure the IDP to add specific user attributes to the SAML assertion. And IAM takes these attributes from the assertion and then tags the user's session with them. So these attributes become the principal tags for that session.
Okay.
As you recall in the previous slide, we had a tagged role per project. I'm just showing it again for continuity. And the session tag allows us to simplify the model. So single role and policy can be used for more than one project. The tags are assigned to the session when it's created, and the value of the tags is controlled entirely in the corporate directory.
Okay, so what do we need to do to enable this?
Okay. We need to add the tag session action to the trust policy of the role that will be assumed. This will allow the ADP to tag user session. And we also can add additional condition that ensures that the IDP is passing tags we want to use for permission control. And if it doesn't, assume role will fail.
Okay, so the IDP will pass these tags to AWS as part of the SAML response?
Exactly. The ADP needs to simply pass the attribute in the format like this in order to tag the session.
Okay.
And when session has been assumed, a role has been assumed, a session has been created, we can see the SAML attributes in CloudTrail for login and reporting.
So maybe we'll show how we move from multiple roles with one policy into just one role and pass the tags on the session.
Yeah, let's do that. So I already pre-created a role that we will use. So first of all, let's edit trust relationships as we discussed. Yeah, I created it originally just for regular integration with IDP.
So we need to add the tag session action.
Yeah, and an optional condition.
The optional condition to make sure that we pass the tag. Okay.
Yep. Okay, so we added the trust relationships, and we don't have any tags on this role. We will not put.
Right, because the tags are coming from the identity provider.
Exactly.
Okay.
Let's add permissions to this role.
So we're gonna use the same ones that we added before. Right?
All right, exactly. So we will use ABAC and common here, and we created the role here. So now we go to the Okta admin console, and because I pulled already integration with AWS, I have all roles in already. So we can directly go to the assignments and assign this role to all our users that work on project 1 and project 2.
Right, and right now you're doing the assignment individually, but Okta and other IDPs, you can do this through groups, right? So everyone in the project 1 group will have that. Okay.
Yeah, exactly. We can assign this to groups. Okay. So we have this now. Let's look at our directory. I already modified a Okta directory profile, and I added a custom attribute project, and I assigned value project 1 to Alice, and I assigned the value project 2 to Bob.
Okay, and this is just an example. You can have more than one attribute that is used as a tag, and you can have any name you want.
Yeah, project, host center, anything. Okay. Anything. You can use standard attributes and custom attributes.
Okay.
So now the question, how do we parse this with the SAML assertion?
Right.
So obviously we need to modify the SAML assertion. So we will go to sign-on configuration, and you can see here attributes that we can insert. I need to mention that this particular feature is in preview in Okta, so you need to contact your support today to enable it. And we will go and use it now. So we will configure PrincipalTag project attribute equals to the user project from the Okta directory. Right, let's save it. And they're supposed to work.
Okay.
Let's go and test it. I'm still logged in as well, but what I would like to do is to look into the SAML assertion that we will be getting. Let's take this line first. And we are in, and this is our SAML assertion that has been captured. And if we look here, we have an attribute.
Okay. Yeah. So you can see
PrincipalTag.
Yeah. So the
project
name is PrincipalTag project, and the value is project 2, and
is
and this is what makes the session have this. So this now becomes the PrincipalTag on the session.
yeah. So
So now, even though we didn't tag the role, right? We didn't make any tags on the role. Now, Bob is supposed to be able to have the same access that he had before.
yes, exactly. Let's quickly test it. We will not create anything else. We will just try to access project 2, secrets, and project 1 secrets, and obviously access that didn't force is the same. It's also interesting to look quickly at CloudTrail. And if you filter a event name by assume role with SAML, you can see the events. And in the event, I took Alice, I logged in with Alice before. So you can see that SAML assertion ID is here and PrincipalTags logged in the CloudTrail.
Right, and this is important again because it's the same username, role session name, it's the same role errand, but it's a new. It can be different PrincipalTags based on the access.
Yeah, it helps greatly with the report.
Okay. So let's say Alice wants to try to escalate her privileges. So as a developer, many times we use CLI and start from one role and assume another. So what if I try to tag the session to another project during the assume role operation? Is there anything preventing me from changing my original project tag?
Yes, you're referring to role chaining, when the role that user assumed has permissions to assume another role and so on.
Okay. So how can we enforce that? Let's say Alice, whose session is tagged with project 1, will stay tagged with project 1 when she assumes role 2 from role 1, for example.
Let's first clarify the scenario we're talking about. Alice has a project attribute in the corporate directory with the value of project 1.
Okay.
She assumes role 1. The project attribute is carried over by SAML, and she gets a session tagged with project equals project 1.
Right.
Now, let's say role 1 has permissions to assume role 2, and role 2 has a trust policy to allow it to be assumed and tagged by role 1. If we define the project tag as transitive, and we'll show you how to set it up shortly, IAM will tag all subsequent sessions in the chain with the original tag value.
Okay, so even if the user doesn't assign any value to this tag, it will just take the one from the beginning of the chain.
Correct.
So can the user add additional tags to the new session?
Yes. If the user adds a new tag, the session will be tagged with it, as long as this is not a transitive tag key.
Right. So if the user tries to elevate privileges and change the tag value for a tag key that was not set as transitive, they will be blocked, right?
Right. If the user tries to change the value of transitive tag, the assume role operation will fail.
Excellent. All right. So which is what we want to achieve. We want to give the user freedom, but keep some reasonable guardrails. So how do we implement this?
The SAML section should simply have an additional attribute called transitive tag keys with the names of the tags that you would like to enforce.
And you can have more than one transitive tag keys by just repeating the attribute.
All right. Yeah, definitely.
Okay, so maybe we'll jump into a demo and show how we do it.
Yep, let's do that. So let's go back to Okta console and edit our SAML section again. And add another attribute, transitive tag keys. And we will put project here. And you can add a list of tags.
Right, I can have more than one transitive tag.
Yeah, if you would like to enforce more. We save this, and now let's test it. Because we can test it only in the console, we will jump to the console from here. Let's jump to there, and we'll test it with the console. Okay, so first of all, I will use a plugin that we will share at the end of the demo to assume a identity with Okta in the command line. And this is my first login, so I need to provide credentials. I will use Alice. So I logged in, and I got Alice assumed role ASM ABAC. We can test it with just getting STS get caller identity. Yep, that's all good. Now let's try to elevate our permissions. Let's try to assume a role and that I already pre-created, and this is EC2 ABAC role that allows us to start and stop instances according to the tags.
Okay, so I see that we're tagging the session, but as far as I remember, Alice is in project 1, but we're tagging it with project 2, so this is supposed to fail.
This is supposed to fail because we put transitive tag equals project. So let's try.
Right, yeah, the error message seems very descriptive.
Yeah, an error message is very descriptive. So Alice cannot elevate permissions with tagging her sessions with different projects. Now, let's try to assume role without tags and see what happens. Yeah, it was successful. And now let's quickly look at the console. What do we have there? So we have a couple of instances. One is tagged for project 1, and the second one tagged for project 2. So let's try first to stop instance that belongs to project 1. Should it succeed?
Sorry, this is for project 2.
That's for project 2.
Yes. So this is the instance for project 2, and obviously it should fail because at least in project 1. Right?
Yes, exactly.
So even when you assume the role, you didn't tag it, and it got the tag from the original assume role that the IDP did from Octave.
Exactly. So I just tried to stop instance that belongs to project 1 that Alice tagged with and succeeded. It means that my tag been inherited from the session that I had before to the session that I got for assuming the second role.
So basically the tag will tag along with it.
Yes. And I can get rid of it.
Is there anything else we'd like to cover today?
This is all. I hope our viewers will find this useful and will take this approach to action.
All right. So maybe we'll do a quick recap. So we talked about the attribute-based access control model and some of its benefits. For example, how we can use it to give developers the freedom to build and administrators the tools to enforce security guardrails in a scalable way, especially in cases where you need to manage multiple projects, multiple departments, and so on with similar access patterns. Session tags allow to create parameterized shared policies that can later be reused with no change. So the user assignment to a project, for example, can be managed primarily in the corporate directory. Thanks for tuning in. We hope this was helpful. And since we have some time left, we'll be happy to try and answer some of your questions.
Yep, thank you.